In this video, I'm going to go over how to perform regression in Google Sheets. Remember that regression is between two numerical variables. We're going to go over to how to evaluate the following hypothesis. Uh, the null hypothesis, meaning that the regression coefficient, or beta 1, is equal to 0. And the alternative hypothesis that beta 1 is not equal to 0. Remember, with regression, we have two coefficients. Looking at the formula kind of right here, we can see that y is equal to beta 0, or the intercept, plus the slope times each times an observation, or x. And so we can use this equation to predict individual scores. We're also going to be going over R squared, or explaining the proportion of variance explained. Briefly, before I want to show you how we go into Google Sheets and show you how to perform regression, this is the regression output that you're going to get in Google Sheets. It is similar to the output that we looked at earlier when we were performing t-tests. It's actually exactly similar, because you can perform t-tests using regression. They're actually the exact same test, but the purpose of what we're doing now is to use two numerical variables, and in this case we're looking at extroversion as predicting some other variable. So this is the predictor variable, and let's say a response variable is number of basketball games attended, and our intercept, or our beta 0 coefficient, is this is our estimate. So remember, our intercepts is the average when x equals 0. So when there's 0, or it's the score when x equals 0. So extroversion, when extroversion is 0, the intercept is 1.401, or that's where the regression line crosses the y-axis. And so this significance test, we have a standard error, a t-value, and significance test, is testing whether this value is significantly different than 0, and a p-value of 0.1707 means that it is not statistically significant from 0. Therefore, we cannot conclude that the number of basketball games attended when extroversion is 0 is significantly different than 0. Oftentimes, we're not really interested in interpreting this intercept variable, so I'm not going to pay too much attention to it. More we're interested when we're doing regression is, as extroversion changes, does the number of basketball games change, or how do these two variables change together? And so for every 1 unit increase in extroversion, we have a 0.055 increase in number of basketball games attended. We have a standard error calculated. We have a t-value. Notice how this t-value is very high, and therefore a p-value is very small. And remember, we're using the same alpha level, or an alpha of 0.05, to determine significance. So in this case, we can reject the null hypothesis that beta 1 is equal to 0, and accept the alternative hypothesis that it's likely not equal to 0, and therefore as extroversion increases, there's a significant increase in number of basketball games attended. We can use these two estimates. We can plug this intercept estimate in right here into beta 0, this extroversion estimate in right here, and therefore if we had a score of, let's say, 50 on extroversion, we can times 50 times 0.055 and add that to 1.401 and get the number of basketball games attended when extroversion is at 50. R squared, I'll go show you more of that when we go into, I think I've shown you that in a previous video, how to get that. It's very simple. but I'll show you that when we get into Google Sheets. So let's go ahead and go over there now. And let's say we want to, in this case, predict number of alcohol drinks per week based on, let's say, openness. So we're going to go over here to add-ons, statistics, and you see we have these two options. Then we could click regression here, but we're just going to click on describe data. They'll give us this very similar output. In the previous video, we're going to click on regression. It'll give us some additional plots that we can be helpful for diagnosing the accuracy of our regression model. But for now, we're going to click on describe data. Now this first variable is our outcome variable, so we want to go number of alcoholic drinks per week. We'll hit OK. And we want to predict that by openness. We'll click OK. We want to add our label here. Let's add person as our label. We're going to uncheck prediction bands and spline fit. And we're going to go ahead and hit create. But before we do, remember that if we only want to do regression on a subset of the data, we can always add or filter variables, which we've gone over in previous videos by clicking there. But let's say we just want to look across all observations in this data set. We're going to go ahead and hit create. And we can see what looks like a slight positive trend going upward here in the data. Our regression fit statistics, as I mentioned earlier, we have an R squared of approximately almost 2%, rounding to the 100th. So that's pretty small. As we go down here, we look at our regression coefficients. This is really what we want to be paying attention to. Remember, our intercept is the number of alcoholic drinks per week when openness is 0, and that's about 3.2. So if this line was to be drawn all the way out to here to our y-axis where x is equal to 0, say 0 is right there, then this is going to be about 3.2. It's a little bit tough for me to write with this marker, but so that's what this is telling us. This is significantly different than 0. So we can say that when openness is 0, that the intercept of 3.2 is significantly different than 0. We're not really interested in interpreting that. What we really want to know is as openness increases, does number of alcoholic drinks also increase? We see the slight positive trend here in our sample. We want to make the inference to a general population. When we go ahead and look at our p-value, circling it right here, we see a p-value of 0.3560. So this is above our alpha. Remember, alpha is conventionally set at 0.05. Because this p-value is above this alpha level, we're going to retain our null hypothesis and reject the alternative hypothesis. And so we're saying that this variation is likely due to sampling variation. And you can think about, if we were to draw several samples of the same data, that it's probably going to be that sometimes it's going to be flat, maybe slightly downward, but all these trends would be kind of around 0 or non-significant. That's basically what we're saying. That in the population, it's highly likely that there's not a significant trend or increasing trend of openness increasing as, or number of alcoholic drinks per week increasing as openness increases. We have an ANOVA table here. You notice how the p-value is exactly the same. Really don't need to interpret any of this information, and the rest of this data is this data right here is just for generating this plot. So that's how you can perform a basic regression. We've kind of gone over how to evaluate these hypotheses. The amount of variance explained is really the effect size for the regression, and basically because the data is so spread out and this line is sort of flat, basically saying that this R squared is saying that not very much of number of alcoholic drinks per week is predicted by openness, only 2%. And that kind of makes sense given that this openness openness does not significantly predict number of alcoholic drinks per week. So 2% of the data is explained by number of alcoholic drinks per week. That's our R squared, or the square of our correlation. In the previous video, I showed you how to work backwards from R squared to obtain a correlation. So just go back to that video if you're interested in that. So it's pretty easy to interpret these regression coefficients. In the next video, I'll go over how to use the regression option in order to perform some diagnostics on your regression model.